Hello, I welcome you all in this presentation related with the subject weldability of metals, and we are talking about the weldability of the carbon steels. So, there are various types of the carbon steels like low carbon steel, mild steel, medium carbon steel and high carbon steels, and the weldability of the carbon steels to a great extent is affected by the composition, because the composition of the steel affects the hardenability and which in turn determines the cracking tendency. Higher the hardenability, lower will be the weldability because of the increased cracking tendency, and to take care of those cracking tendencies, special precautions are needed, and whenever there is a requirement of the extra efforts to perform the same job, that in turn reduces the ease of welding as far as the welding is concerned. We know that there are different types of the welding processes which are used for welding or joining of the metals. So, if we talk of the few welding processes, most of the most common welding processes are based on the fusion based welding processes like shielded metal arc welding, gas metal arc welding, gas tungsten arc welding, submerged arc welding, plasma arc welding, gas welding, laser welding, electron beam welding. In all these cases, the fusion of the fing surfaces is facilitated in order to have the metallurgical continuity. So, in any case we have to supply heat using the suitable heat source, either it is the like it is in form of the radiations, or it is in form of like chemical reactions leading to the combustion of the fuel gas to produce the heat, or it is in form of the welding arc. Each of these source results in the different approach as far as the protection of the weld metal is concerned, as well as each one of these processes will be different with regard to the kind of energy density associated with that particular heat source. Say gas welding offers the lowest energy density among these processes. So, it requires the highest heat input to facilitate the fusion for a given set of the welding conditions. On the other hand, the highest energy density is offered by these radiation based processes, and therefore, these result in the lowest heat input. On the other hand, the processes which use inert shielding gases like the plasma arc, gas metal arc or gas tungsten arc, even in laser beam also sometimes inert or inactive gases are used for protection purpose. Since the ease of welding to a great extent depends upon the extent of damage which will be taking place in the heat affected zone due to the heat application during the welding, as well as the quality of the weld metal is affected by the kind of protection which is being provided during the welding. And that is why depending upon the type of welding process which is being used, you will be coming across the different degree of the weldabilities, or the weldability of the different metals will be different for the different welding processes. So, now we will be starting with the weldability of the carbon steels for the shielded metal arc welding processes, and what are the aspects that we have to look into. So, the weldability of carbon steels with regard to the shielded metal arc welding process. So, in this presentation I will try to talk about the weldability of carbon steel of these three processes. One is the shielded metal arc welding process, another will be the gas metal arc, and gas tungsten arc, and plasma arc welding processes. So, this is one category basically, and then also we will try to see the weldability with respect to the flux core arc welding process. So, since each of these processes will be having the different protection approach as well as the kind of the consumables which are used, consumables in terms of the electrode, shielding gases, the kind of fluxes which are used, these are different, and that is why you will see the issues which are encountered during the welding of the carbon steels are found to be different. So, as far as the SMAW is concerned, shielded metal arc welding process, this is also known as manual metal arc welding process or stick electrode welding process. This is one of the most commonly used welding process because of its easy to use and flexibility to apply the molten metal at the required places. So, as far as the SMAW is concerned, it uses the consumable flux coated electrode, which during the welding process itself is consumed, and thereby it helps to deposit the metal at the required place in the process during the process of the welding when the arc is established. So, establishing the arc facilitates the fusion of the fixed surfaces as well as the fusion of the electrode itself, and this metal gets deposited. At the same time, the coating with the electrode is thermally decomposed, which provides the inactive environment for protection of the molten metal from the atmospheric gases. At the same time, whatever slag is formed due to the interaction of the interaction of the flux with the molten metal, this slag also provides the protection to the molten metal from the atmospheric gases, so that the contamination of the weld pool from the atmospheric gases like oxygen and nitrogen can be reduced. The kind of the energy density and the protection approach which is associated with the SMAW process, that is good enough for welding of all types of carbon steels, ranging from low carbon steel, mild steel, medium carbon steel and high carbon steel, except the problem may be that when we are working with the thick sections of the high carbon and medium carbon steel, we may require preheat. So, the preheat requirement will be influenced by the carbon equivalent as well as the thickness of the plate which is being welded. Otherwise, low carbon steel and mild steel can be easily welded using the shielded metal arc welding processes. So, the kind of the electrodes which are used in during the shielded metal arc welding process, these electrodes are classified on the basis of the three broad factors. One is the composition. So, what we say, it is either simple carbon steel electrode or the alloy steel electrode. The second is the mechanical properties, the kind of the mechanical properties which are offered by the as deposited all weld metal specimen, not the transverse section of the weld joint. these are about the properties of the all weld metal samples, and primarily these are characterized or specified in terms of the UTS, the ultimate tensile strength of the weld metal. Another one is the type of the coatings or the flux which is being applied. So, as far as the properties are concerned, the properties may be like 60 KSI, 70 KSI or up to 120 KSI. So, as per the strength requirement, the electrode of the suitable matching mechanical properties or the tensile strength can be selected. Then there is another aspect, that is about the type of coating. This type of coating determines the kind of the cleanliness of the weld metal or the kind of the low hydrogen electrode characteristics. So, there are various types of the coatings are available. Most commonly used are like rutile coatings or the rutile electrode, cellulosic coatings on the cellulosic electrode, basic coatings for the basic electrodes. So, for low hydrogen electrodes, basically basic coatings are used. Then there can be the combination of the rutile and the cellulosic or the acidic and the rutile electrodes. So, acidic electrode is the another category or another type of the coating material. So, for most of the non-critical applications, rutile and cellulosic electrodes are used, but for the critical applications and for the low hydrogen situations where we want that process is performed under the controlled low hydrogen environment, then the basic electrode coatings are used. So, this is how the electrodes are grouped or the classified for the SMAW, and then there is a typical way to understand the kind of the strength which will be offered by the typical weld joint which is being developed using the SMAW. Like if the electrode being used is 60 XX is the kind of the designation which is used for the various constituents which are there in the weld metal, and then 60 XX, this indicates that the all weld metal properties will have the strength of the 60 KSI, while the E70 XX will show the 70 KSI, the weld metal strength, and this can range up to 120 XX, which means 120 KSI. So, this electrode designation itself will indicate the kind of the tensile strength and the mechanical property combination which will be offered by a given electrode, and accordingly so according to the strength requirement we select the suitable type of the electrode for the welding purpose, so that the required combination of the strength and the properties can be realized. For most of the low carbon steel and mild steel joining, E600 type of the electrode is used. Even this type of the electrode can be used for joining of the medium carbon steels and the high carbon steels if the strength requirements are satisfied by the joint which are being made to connect the members of medium or high carbon steels member. Mostly this is used when the no low hydrogen conditions or the process conditions are to be realized. For the low hydrogen conditions, the another type of the electrode is used, like E70XX. This electrode is produced in both regular formats and the low hydrogen kind of the electrode. So, low hydrogen electrode means the coating will be of the basic type, while it can be cellulosic or the rutile type for the regular electrode purposes. So, mostly for the conditions where high strength steels or high carbon steels are to be welded, there we prefer to use the low hydrogen electrode, so that not just the matching strength is realized, but using the low hydrogen, the cracking tendency, using the low hydrogen electrodes, the cracking tendency is reduced. And so therefore, for all critical applications where SMAW welding is to be applied for welding of the medium carbon steel, high carbon steel or other high strength steels, low hydrogen electrodes are used. So, the typical low hydrogen electrodes include like the LHE 7015, 7016, then 7018 and 7048. So, these are the common low hydrogen electrodes with for the different concentration or different alloying elements produced in the low hydrogen format or low hydrogen variant, and most of these steels are designed to have the very low carbon content. So, not just the low hydrogen is facilitated, but the carbon content is also less than, normally it is less than 0.5%. So, lower carbon content, lower hydrogen level associated with the weld metal, while some of the carbon will be coming from the base metal due to the dilution effect. So, in order to neutralize the high carbon content coming from the base metal, normally the very low carbon content, these electrodes are designed using the very low carbon content, so that the associated hardening and the cracking tendency can be reduced. Another one, the now next process is the gas shielded arc welding process. So, this is a category of those welding processes where the shielding gas is used for protection of the weld metal, like the heat source and the base metal is being brought to the molten state. So, in the molten state this becomes very active, and if has a high affinity to the environmental gases, then the atmospheric gases like oxygen and nitrogen will interact and will produce their oxides, nitrites. These gases will have tendency to get dissolved. So, will be leading to the inclusions as well as pores. So, in order to reduce those tendencies, effective protection of the weld metal from the atmospheric gases becomes important, and that is why we need to use the so in certain processes the shielding gases are used for effective protection of the weld metal from the atmospheric gases, and this includes the gas metal arc, gas tungsten arc and the plasma arc welding processes. So, wherein although these processes differ from each other significantly, like gas metal arc welding process, this process uses the consumable electrode, while the gas tungsten arc and the plasma arc, both these use non-consumable tungsten electrode. So, in this case the whatever electrode is there, its composition is to be identified in such a way that it helps to satisfy the requirement of the mechanical properties, composition, response to the heat treatment, so that we can get the properties as per the requirement of the weld joint. While in case of the gas tungsten and the plasma arc welding process, we use the tungsten electrode which does not melt in course of the welding. So, in order to fill the gap and in order to deposit the metal from outside, in this case the bars and rods of the suitable composition and properties are used, so that the matching strength, matching response to the heat treatment and composition can be realized. So, this is the basic difference in these processes, but in all these processes we use the external shielding gases. It is called forced protection, where a jet of the shielding gases will be coming out of the nozzle and will be covering the pool by pushing the atmospheric gases away from the molten metal, so that the effective protection is provided by these welding processes. So, when we use the bare electrode, in case of the gas metal arc welding, there is no coating over the electrode is bare. So, the bare electrodes are classified based on the composition, whether it is carbon manganese electrode, simple carbon steel or alloy steel. Similarly, they are also classified based on the mechanical properties, like how much strength will be offered by the all weld metal properties, and because that will be used as a primary criteria for selection of the filler for developing the weld joint of the matching strength, and these are designed to have the strength from 70 to 120 KSI. So, as per the requirement, we will be choosing the bare electrodes of the suitable mechanical properties, so that the joint of the required strength can be realized. Rest of the like the factors associated with the selection of the bare electrode, its composition and properties, those factors will be similar to that what we have talked for the SMAW process. Now, another important aspect related with these welding processes, the shielding gas, because shielding gas, apart from the bare electrode which is used in these processes, another important aspect is the shielding gas. So, the shielding gases which are commonly used in these welding processes, like in GMAW, gas metal arc welding process, about which we have just talked, like it can use the CO2, argon plus CO2 or argon plus oxygen mixture. So, since the CO2 acts as a becomes inactive to the ferrous systems. So, when it the reasonable quality of the weld is needed at low cost, CO2 is used as a shielding gas, and for most of the low carbon steels and the mild steels, the CO2 is very commonly used as a shielding gas in case of the gas metal arc welding process. Thereafter, we have the argon plus CO2 and argon plus oxygen, and then sometimes we may also use the argon plus helium gas mixture. So, but when argon plus CO2 or argon plus oxygen gas mixture is used, it helps in these are used for alloy steel and the high carbon and medium carbon steel welding. And the kind of the weld metal properties which are offered by the CO2 and the oxygen when the argon is mixed with the CO2 and oxygen, the kind of the joint strength is good in terms of the toughness, as compared to the case when we do not use the oxygen or the CO2 as a mixtures with the oxygen, because the presence of oxygen in the shielding gas promotes the delta ferrite formation or acicular ferrite formation in the weld metal, and which in turn helps to increase the toughness of the weld metal. So, CO2 plus argon and oxygen plus argon, these gas mixture helps in improving the toughness of the weld metal. When we use the GTAW process and PAW process, invariably the argon is used as a shielding gas, and helium for extremely high quality weld joints, even helium is used. And when we want to take the advantage of both argon plus helium, then mixtures of the two is also used, where argon plus 25 to 75% helium mixtures can be used. Helium results in very high heat input, increases penetration, it increases the welding speed, it increases the productivity. On the other hand, it offers very good arc stability of arc, it offers very low the good reasonable quality at low cost it offers. And if you want to take the advantage of both, then the mixtures of the two are used. Now we will talk of the GMAW process, when it is used for the welding of the rimmed and capped steels. We know that the rimmed and capped steels are known to have the high oxygen percentage, and when these are welded, when the base metal of the rimmed and capped steel type is welded, the higher oxygen content with the steel will be leading to the development of the pores and oxides. To take care of this, normally the filler rod or the electrode which is used, that must have the high percentage of the deoxidizers. So, the most common electrode which is used for to satisfy this kind of requirement is E570S2. This is one of the most commonly used the bare electrode, which helps to take care of the issues related with the rimmed and capped steels. And when these are basically low hydrogen processes, because there is nothing like the moisture which will be absorbed with the flux coating, and after decomposition it will offer the moisture H2O, and which on decomposition further will be providing the hydrogen. In general, these are the low hydrogen processes, but if we do not care for proper surface preparation, especially with regard to the cleaning of the paint, oil, rust, dust, etc., from the base metal, from the filler metal, or from the electrodes, or the electrodes have not been properly stored, or the gas mixture is having the moisture, or there is air aspiration during the welding, or the leakage of the air into the shielding gas pipeline. So, all these can lead to the presence of hydrogen in the weld metal. So, if we do not take proper care with regard to these points which can act as a source of the hydrogen, then the low hydrogen characteristics of these processes like the gas shielded arc processes, gas metal arc, gas tungsten arc, and the plasma arc welding process, then all those benefits are reduced, means low hydrogen related benefits are reduced, which is otherwise available with these gas shielded arc welding processes. Now, I will summarize this presentation. In this presentation, basically I have talked about the weldability of the carbon steels and how it is affected when the shielded metal arc welding process and the gas shielded arc welding processes are used. Thank you for your attention.